All right, this is the last video for this section. We're going to do these last two examples, 104 and 105. On 104, when we're trying to figure out what our u should be, there's nothing that jumps out as being inside of something else. So what should we let u be? Well, one thing you might notice is the denominator here, x cubed plus 1. The derivative of that would be 3x squared, and that does show up on the top. So I'm going to treat this denominator as my u. So u is going to be x cubed plus 1, and du then is going to be 3x squared dx. So I can rewrite this as integral of just u on the bottom and du on top. Now you can write it like that, or you could write it as integral of 1 over u du, either way. And that's an easy thing to integrate. What about my endpoints? Well, let's see, for the top, I'm going to let u equal, let's see, I'm plug it into here. So I'm plugging in the e. So u is going to be e cubed plus 1. And on the bottom, I'm going to get u is 0 cubed plus 1. All right, so 1 to e cubed plus 1. All right, now when I integrate 1 over u, that becomes ln of absolute value of u from 1 to e cubed plus 1. So I get natural log of e cubed plus 1 minus natural log of 1. Now natural log of 1 is 0. So this is just going to be natural log of e cubed plus 1. And unfortunately, I can't really do anything for that because you can't break a natural log up when it's two things added together. So we'll just have to leave our answer there. Now, just for fun, let's see what it is on the calculator. If I do e cubed plus 1, I get like 21.08. Take the ln of that. It's like 3.0485, blah, blah, blah. Let's check it on the Riemann sum calculator. Sometimes my words don't come to me as quickly as I would like. 3x squared divided by x cubed plus 1. Looks like that. All right, but we're supposed to go from, what was it, from 0 to e? So 0 to e. And look at the integral, 3.047. And that's with 1,000. If I change it to 10,000, 3.048, and so on. So yeah, pretty good. All right, let's look at the next example, the last example. All right, integral of tan x from 0 to pi over 4. All right, so let's do this one and get the approximate answer. What was it? Tan x from 0 to pi over 4. Tan x from 0 to pi over 4. Let's see. I'll put in 10,000 rectangles. Let's see, this is 0.3, 4, 6, 5. That's the approximate answer from the calculator. Now let's go back and do it. Now this one, right off the bat, it might be difficult to figure out how to do this because we don't have any trig function whose derivative is tan. And don't even think about secant squared. The derivative of tangent is secant squared. We've got to find the antiderivative. So the thing to do with this is first rewrite it as integral from 0 to pi over 4 of sine x over cosine x. And now for my substitution, I'm going to let u equal cosine x. That way du, derivative of cosine is minus sine. And notice, if I multiply both sides of this by -1, I get minus du is sine x dx. All right. So the cosine downstairs can be replaced with u, and sine x dx can get replaced with negative du. And now my top and bottom. On the top, u is going to be cosine of pi over 4, which is root 2 over 2. And on the bottom, u is cosine of 0, which is 1. So I get that. Now I'm going to do one more thing here. I'm going to bring this down to the next page where I can write it more neatly. I've got 1 root 2 over 2 du over u. And I've got that negative, which I'm going to move out front. Now, just for convenience sake, I'm going to get rid of that negative. Remember, if you get rid of the negative out front, what that does is reverses where your it reverses your endpoints. So I can get rid of the negative by just swapping the root 2 over 2 and 1. And this seems a little more natural anyway, because root 2 over 2, that's like 0.7071. And it seems more natural to have the lower endpoint on the bottom. It doesn't really matter, but I don't know, it seems right to do that. So what do we get here? We get ln of absolute value of u from root 2 over 2 to 1. So if I plug my endpoints in, I get ln of 1 minus ln of root 2 over 2. Now ln of 1, this is just 0. Now this other one, minus ln of root 2 over 2, I'm going to break that up. Just because we could write this in a nicer way, I think. This is ln root 2 over 2. I can break that into minus ln of root 2 minus ln of 2. Actually, I don't want to do that. That would work, but there's a simpler way of doing this. Let me back up just a little more. I'm going to rewrite root 2 over 2 as 1 over root 2. You should realize those are the same things, but if you don't, just check this out. If you've got root 2 over 2, you could factor the 2 into square root of 2 times square root of 2 and cancel. So anyway, I can rewrite it like that. And so I get minus ln of 1 minus ln root 2. And of course, distribute the negative across, you just get ln of root 2. And that's the exact answer. Let's compare that with, what was the approximation I got earlier? The approximation I got earlier was this, 3.04858. Tell you what, let's do that on here. Wait a second. Actually, this is not the correct, that's from something earlier. Something that's just a random number that happened to be in my calculator. I found it up here, 0.3465. Let's compare that to natural log of square root of 2. When I do natural log square root of 2, I get 0.34657. But anyway, this is the exact answer. Natural log square root of 2. All right, well, that's it for this section. And I guess that's it for the semester. So I hope you guys have enjoyed class as much as you can. And anyway, I've enjoyed teaching you. So take care.